So in this question, we have two naturally occurring isotopes, and we have the percent abundance of both of them and their corresponding atomic masses. And we're asked to find the atomic weight of the element, or the average atomic weight of the element. Sometimes it can be also called the atomic mass, and it's going to be the average. And with this number that we're looking for in this question, this is the number that's going to appear on the periodic table. And so we have these two different isotopes. So they have different masses because they have different number of neutrons, same number of protons because they're the same type of element. But what we're going to do is we're going to do an equation for this. And the equation is going to be that to find the average atomic mass, and I can say the weight or the mass, I'll put mass here, the average atomic mass, that's going to be equal to, you're going to take the percentage of the first one, and you're going to multiply it by the atomic mass of the first one. So the atomic mass of that first one. And so once you take the percentage times the average atomic mass of that one, and then you're going to add it to the percentage of the second one times the atomic mass of this second one. And basically, we're going to stop here for this equation because we only have two naturally occurring isotopes. But if you had more, then you would just like keep on doing this. You would do this however many times for however many isotopes that we have. And so what I like to do for these types of questions is I like to take my percent abundance here and underline it, and underline the atomic mass that it goes with, just so I know to keep those two numbers together. And then what I like to do is take this second one here and underline that one, and then underline that one. And if you're working in pencil, you might want to like put two lines under this one, and then put maybe one line under this one, just so you can help keep track of those. Since I have some colors here, I'll do this in colors. And so what I'm going to do is I'm going to take the average. I'll just put average here so it makes it a little bit shorter. It's going to be equal to, we're going to take the first one, and now we have a percentage here, and because we're multiplying this, we want to convert this to a decimal. So we're actually going to divide this by 100. So this is going to be 0.374, and then we're going to multiply that by this number here, which is going to be this 184.953, and then we're going to take that and multiply, or sorry, we're going to add that to this next one, which is going to be this this 0.626, and we're going to multiply that by this 186.956. And so what we're going to get is, when we solve this out by multiplying these, we're going to get the average. It's going to be equal to this first one. That's going to be 69.172, and then we're going to add that to this next one, and that next one is going to be, let's see, this is going to be 117.034. And so now what we'll do is we'll just add those numbers up. So the average atomic mass, or the atomic weight of this, is going to be equal to 186.206, and that's going to be units of atomic mass units. And this is going to be the average atomic mass of this particular isotope. And if you want to know what this element is, we can go to the periodic table, and then we're going to look at that. Usually it's going to be the bottom number on the periodic table, the atomic mass. But depending on your periodic table that you have, it might look a little bit different. So you might look at the key, but this is going to be the average atomic mass that we can now find on the periodic table.